This conference will now be recorded.
Okay. Hey, good morning, everyone. And thanks for joining again.
Good morning.
My name is Adam. Yep, very good morning.
Good morning, Adam.
Good morning. So today's agenda will be, the continuation of what we have seen yesterday. So we saw that how do we create and manage containers. So from that, what we will do, we will learn some concepts called port mapping, and we'll learn some other new concepts called data volumes. And from that, we will see how is that we will be able to generate or build our own Docker images. Because until the last session, what we were doing is, if there was an image which was already available, we were trying to use it. But now we'll try to see how is that we can create our own images. Okay. Now, in that, the first topic that I would like to cover today is port mapping. So what exactly is port mapping? So let's try to understand that first. So let's go back to our traditional method. Now, assume that there is a web application that you want to install and run it and then try to use, which could be you or someone else trying to access it. Okay. Now, when you say that you're going to install a web application, now what happens? You take a machine, right? And you go ahead and you install an application in a machine. Now, when you install an application on a machine, then, and typically if it's a web application, there will be a port number associated to it, right? So different applications has different port number. So in that way, now let's assume that I have taken application or something like a web server, okay, something like Apache. Now here, that application will be associated with a port number called 80, which will be on that particular host machine. Now, if you want to access this or someone else wants to access this, then what is that we are going to do? So we are going to refer to the host machine's IP and the port number specific to your application from the browser, so that from whichever browser or a different machine that you're accessing, you will be able to reach this application, correct? So in that way, when you try to access it, then the connection from the URL or the machine that you're trying to reach will be coming to the port which is available on the host machine, because you'll not be able to reach the application directly, but through the port number which is visible in the host machine, right? So this is the default way. In the similar fashion, now if you have another application, let's say that you have an application like Nginx which is running on port 8080. So again, how is that you are going to access Nginx which is running on 8080 in a particular machine? Once again, you're going to use the machine IP and the port 8080 to access. So that way, that will particularly allow you to connect. So all the connections are happening through the port number which is listening or visible on the host machine. So that is the simple way how we will be accessing. Now, since we are looking at the container way of working or the world of containers, what is the difference? So the difference is now, instead of creating or running an application directly on our machine, this is what we have been learning from the last couple of sessions, that I can create a container and run inside it, so that we get the isolation and it doesn't mix with any other application, right? So instead of running anything directly, we saw how easy it is for us to create an environment called as container, and we will be able to run everything inside it. So that way, now if you take the same application, instead of running on the host machine directly, if we run it inside a container, then what happens? So if you look at closer, every application that you install in a container will be residing inside the container because it has a layer. The same way, the port number, whatever the application will be giving us, will be listening only on the container level itself. So now what happens if, let's say, I took a container and inside the container I have my Apache server running, then if I want to connect to this from outside, then what happens? If I try to connect, then the connection from the URL will always search for the boundary of your machine only, because we will never be able to go from the URL directly to the container or inside application. The same way over here, when you try to connect through a URL, the need of the port is to allow you to connect between the application and the user, right? Because this acts as a gateway or the connection between the user and the application. So the same way, if you come here, when the user is trying to connect, the access from the URL will reach only the host level. Okay. Now, however, the user will be able to connect only if the port number is available on the host machine. But now what is happening? Available, but it is not directly available on the host machine, but it is available inside a container, which is again a separate layer, or as we know that containers, anything that you put inside it will encapsulate. So that is where, just like how you had the applications port directly on the machine, when you create a container, the application will have the port associated to the container. So the only way now we can access this is if the port is created on the host machine. Okay. So now, how do I do this? Because if the application is inside the container, the port will be available inside the container only. But however, if you are trying to access it externally from another machine, then this connection will come and check only on the boundary of your host machine. Okay. So that is where in Docker, there is a concept called port mapping, for which we have to do two steps. Okay. So the first activity that we have to do is we have to expose the port number which is coming from the container. So expose means we are going to tell, when we are creating a container, is there a application which is a web application and it wants to share some port number which is available inside the container to the host machine. Okay. So as the name says, expose. So expose means the container is going to tell to the host machine that, hey, these are the port numbers which are available in me, which I want you to know. So that it is letting the host machine know that these are the port numbers which are available inside it. So this way, when you create a container, you have to do a expose and tell specifically what is the port number which the container is going to expose or share it to the host machine. So that is the first part. So this way, the host machine will now know what are the port numbers which are available on the particular container. Then, once a port number is being exposed by a container, then we need to map that to the actual port number which is available in the host machine. So this way, what happens, whenever there is a container which you are starting, and if it has an application which is exposing a port number, and if you map that port number to the host machine, then now if you see, in order to access this port number inside the container, if the user tries to reach the port number which it has mapped on the host machine, so the connection will come here. So now when you try to reach this machine, the connection will come to this port, and this port internally is nothing but a map or a link to the actual port which is available inside the container. So this is the only way we will be able to access the applications, which is a web application running inside the container. So this way of linking or exposing the container's port and mapping that to an available port on the host machine is what we call it as port mapping. Okay. So now, like this, I can have multiple containers, and every container can have different port which is being exposed. So this way what happens now, for example, let's say that we have another container in which I have this Jenkins running, or I have Tomcat running, which also runs on 8080. Now what happens when I have the application running inside the container? You need to first expose and then map to a port number which is available on the host machine. So this is where, when you are trying to expose, you can expose whatever port number is available inside the container. But when you are trying to map, the mapping of the host machine refers to a port number which is available. Okay. Now, for example, here if you see, let's say there is some other application already running on the host machine and it has already taken port 8080. Then this is where, when you are trying to map a port number on the host machine, then you will not be able to use the same port. Okay. Even in this case, if when I am trying to map a port on 8080, we need to make sure that in the host machine there is no other application using port 8080 or port 80. So that way, only when this port 80 is free, we will be able to link. But if port 80 is already taken by some other application, then you need to give any other available port. So that way, here when you try to map, if the required port whatever you are expecting is not available, then you need to make sure that whatever is the available port, you can go ahead and give the map. Now let's say, for example, in this port 8080 is not available for me because some other application has taken. Then if I say that, okay, I found 8081 is available, then I can go ahead and give the link in this way. But now if a user wants to access this application, then he needs to say the machine IP colon 8081. Okay, so it's not 8080 because the only way the user can reach this is through this port which has been mapped and available on the host machine. So now let's assume that you are running Jenkins inside the container. So if you want to access this, then looking at this diagram, you can say that you will say HTTP your machine IP colon 8081. Then what will happen? The connection will come here and this will internally map you to 8080. The same way here, just an example, instead of 80, let's assume you are giving some other port number. Then what happens? If you want to access this, whatever the port that has been mapped on the host machine is what you are going to give. So it's not mandatory that whatever the port that you are exposing, you should be mapping it the same, because this is coming from the application directly. However, when you are mapping, you need to make sure that the port that you want is available. If not, you can choose any other port which is available and you can map to it. So that if you want to access this application, you should always use the port number which has been mapped to the host machine. So you will reach the port which has been mapped to the host machine, and this will internally connect or help you to connect to the port which has been exposed. Okay, so this is what we call it as port mapping. This way you can have different containers in which you will be having different applications which has been exposed to the host machine. However, we need to make sure that for every application, what is the particular port number that is available on the host that we need to map. In some cases, the port what you want directly, which is exposed from the container, can be mapped, but if it is not available, then that is where whoever is creating should be aware of what are the available ports in that machine and choose some other port. Okay, now like this, it is not again mandatory that from one container only one port will be available, because the default logic is in one container you will be typically running only one application. Okay, because if the question comes like, okay, can I run two applications in a container? Now again, that's not the whole purpose of creating the container, because that is what you were directly doing on the host machine, right? Instead of creating and running multiple applications on a host machine, you are trying to split it and keeping it as different containers so that you are free for different environment. So that's when the point is, again, inside a container you don't have to run multiple applications. But my point, what I was trying to tell is, there are cases where one application can run or can give you different ports. Okay, now let's say if you are trying to run some kind of application server, there will be something called as debug port also. Okay, so that is where there are cases in which one application can give you different ports. So one port is for accessing the console of that, or there would be another port where the users or the developers can directly access and debug. So that way there could be one application port, there can be one debug port. So that is dependent on the application. But to show or to tell the example, now let's say in this container the same application is exposing another port. So now again, if you want to expose this and map it to the host machine, we need to first know, do we have the same port available on the host machine? If not, whatever the port is available on the host machine, that will be mapped. So now if you want to access this application through port 7001, then from the host machine, if you reach 8082, then internally that will be mapped and allowing you to access 7001. So this is how every application will be mapped to a particular port number which is available on the host machine. Okay, remember this. So this is what we call it as port mapping. And one point which is important to note this is, when we are creating the container, at that point of time we should map it, which means, let's say I created a container, and while creating the container I mapped the port number here to 8081, just a assumption. Then once the container is running, you cannot change this 8081 to any other port because it will be allocated. So as long as the container is running, this mapping will be available. Okay, so after creating the container you cannot change. So typically when you are going to create the container, at that point of time you need to decide what is the port mapping you should do, and accordingly you should be creating the container. So port mapping will be done at the time of container creation. So this is where we need to first know what are the available port on our host machine, and we should also know that what is the port number which is going to come from the application. So this way, when you say docker run command and map, you will be mapping this. However, we will not be doing the actual exposing. So the actual exposing will be done by the image. Okay, so what you are going to do is, when you create a container, you will just say what is the port which is coming from the application or the container, and what is the port that you have on your host machine. So this is how you are going to do a map. Okay,
Adam, I have a
any
quick
question?
question. Yeah, I had a
Yeah,
quick question. This is Raghuram here. So when you launch multiple instances of the same application, right? So then how do you map the ports? Like if you're launching multiple instances of applications on different containers.
yeah, now this is
Same
where, like
application.
I said, yeah, I got the question. That is what I was trying to tell you here. So if you look at this diagram, now let's assume
Yeah.
instead of this 8080, it is also 80. Then this application's 80 is mapped to port 80 in the host machine. Same way, if this application is also 80, I can map it to 8081. So if you want to access this instance of the application, use machine colon 80. If you want to access this instance of your application, then use 8080. So it's all about giving the mapping. So you can have the same application running on multiple containers, but it is not the same port which you're accessing through the machine, right? So if you say machine IP colon 80, it will go to the first instance. If you have another
Okay.
instance running, if you map to another port, it will work. So this is how each container is separate, and for each containers application you will have a different port. That's the reason that I was giving you this example. So that's how you can
Okay.
create multiple containers and you can access them. Okay, Now,
Hello,
if
Adam.
this is clear,
Hello,
yeah,
Adam. This
go
is
ahead.
Ashok. Sorry, I think this question might be not valid. I just want to confirm. So, to follow up that question, right? When we have a multiple instances in the containers, do we have any provision to have a load balancing so that uh, port is exposed to, like, let's say example port 8082, so that can route to the different instances?
Yeah, there are two ways that you can achieve it. Now,
Okay.
if you want Docker to do a load balancing, there is actually nothing called as load balancing in a very straightforward way. Now, you need
Okay.
to use an external load balancer. That is one way
Okay.
you can do. But for doing it, your basic Docker system will not be sufficient. So that is when we need to get into the mode called orchestration mode. Okay. So that's
Okay.
where you have different tools called Swarm or Kubernetes, using which you can manage multiple containers. If not, just by using a Docker daemon which is available on a single machine, you will not be able to do it straightforward. But however, for this machine, I can go ahead and put a load balancer, which is an external load balancer. Then using that, I have to do a mapping. So it will not be possible in a straightforward way. But yes, that's the whole point. When you go into orchestration, you will be able to use multiple machines, in which whether the container is running on the single machine or multiple machine, you will be able to handle them. Okay.
Okay, so it is not possible within the machine. So different instances, multiple instances.
You can, but with just one Docker daemon, it is not possible because it is
Okay.
kind of running in a standalone mode. So you need to run it
Okay.
in a group mode or a cluster mode. So that is possible only when you have something like Swarm, or to the next
Okay.
level, if you use something like Kubernetes, it is possible.
Okay. Okay. Thank you. I think I got the answers. Thank you.
Okay. So I'm just using the same machine what I created yesterday. Right. So now, so let's go back to what we were seeing yesterday. Now here, in order to create a container, come back to this. Yeah, this is what we had. Okay, so now if you go back, okay, so this is what we were trying to use, and I was giving you a couple of examples. Now in this, in the Docker run, okay, so you are going to use an option called, okay, probably I'll put it here, it'll be simple. Use an option called P, a small p, which stands for port mapping. So here you are going to tell two things. One is you are going to tell the host port colon container port. Okay, I'll put it in a simple way here, -p HP, that stands for host port, and CP, container port. Okay, so now if you understand, whatever that you have on the right side is the port which is being exposed from the container, and whatever that you give on the left will be the one which is being available on your host machine. Okay, so to show this example, let's say this, then if I'm creating a container, then here the port number will be 80:80. So this 80 is container, and the left 80 will be my host machine. Okay, now I can give multiple ports also being exposed. Like, let's take this example. Now in this, my container is 8080, which is being exposed, whereas the host machine has 8081. Then if you come here, it will be 8081:8080. So that left hand side is your host port, and the right side will be your container port. Okay, and now if I want to expose another port, then go ahead and say -p, and this one, 8082 to 7001. So I'll say 8082 to 7001. Okay, so this is how, when you're creating a container, you need to keep this. Okay, so this is where you need to first make sure that this port is available on your application or on your container, because Docker will never care whether this port is available or not. It will just try to do a map. But this is what goes to our responsibility, where we need to use an image in which we will say that there is an application running and that is exposing the port whatever that we have given, and that will be mapped. So if this port number is not available on the machine, then you will get an error. Okay, so to start with our example, okay, so what I'll do now, let us use an image where we will be having Apache. Now this is where, if you go back yesterday, I was telling you that there will be an image available in the registry. Based on your need, you are going to download it to your machine, and from that create a container, which is what we call it as container management. In that, whatever is available on the image, you are going to get it inside your container, right? So this is where, now let's take up to the next level. Rather than using just the plain flavor of OS, because whatever that we used yesterday for seeing the demo, we call them as vanilla flavor. Okay, so it's kind of nothing is there much. All you have is only the base image, which has the minimal files to treat that as a OS. But now you can choose an image which has applications also already installed into it. So that way, now what will happen? If you take the image, now let's say that there is an image in which Apache is already installed. So now if I take that image and if I create a container, then what happens? You are not going to just get a container, but the container will have all the files which is available inside the image. So that way, the container will get the Apache server already available inside the container. It is like pre-installed for you. Okay, and not just that. The next thing is, who is going to start that? So that is where, if you go back to the basics yesterday that I was telling you, if you do not tell a startup command, then whoever has created the image has to make sure that there should be some startup command given. So that is where, now assume that if I am creating the Apache image, I will create the image in such a way that the startup command will actually start the Apache in that image or in the container. So that way, what happens, if you are a user and I just give you the image of Apache, all you have to do is run it. When you run without passing any first command, automatically Apache will be started inside your container. So that is where I was telling you yesterday that there are cases where you will be actually using first command, wherein without the user's knowledge of knowing internally, you can just create an image which will start the application whatever is needed inside it. Okay, so to understand that example, now let me first take an image called Apache. So there is the image called HTTPD. So this is an Apache image. Now in this, what happens is, now first, this is the image name. Now how do I create the image? So again, we have two modes of creating a container. I'm sorry, how do you create a container? So there are two modes. One is interactive mode and detached mode. So this is when my interest now is not to create a container and go inside and do some activity. My interest is to create a container in which there is an application which is going to run, like Apache. Then if that is the interest, then I am not interested to go inside the container. Then what you will be doing is using -d. Okay, because I want the container to get created and it should be running in the background, and I'm not interested to go inside, just to access the application which is running. So that way, let's say the name of this is Apache, and now here we are going to say the port number and 8080. Okay, so I'm assuming that in my host machine there is no application running on port 80, so I can go ahead and give, just in case if you want to cross check. Now let me just quickly check whether there is port 80 running in my machine. Okay, so you can see there is port 80 free, so I can go ahead and use it for my mapping. So this should be good. And now after the image, I'm not giving any first command, because let's assume that I don't know what is the command, or I literally don't know what is exactly available inside this as an application, and I do not know where it is installed, what will be the command, right? So in those kind of scenarios, if I leave it blank, then whoever created the image should have created in such a way there should be a first command which should start the application which will be available inside. So in this, if I say Apache, then whoever created this should have given the startup command in such a way that the application that is Apache would also get started. So how do you create this? That is where we need to learn in the image management. Okay, so now let's go ahead and execute this. So when I run, what happens? Once again, it's the basics. We do not have the image, so you can see that it is trying to download the image. And once it is done, it will create the container, run the container in the background, because we have what we have given as an option called -d. Okay, then so you can say docker ps, and you can see that it is running, and internally you can see that it has been mapped here, so that your containers port 8080 is mapped to the host machine. And now if I want to see what is running as a console output, then go back to what we learned yesterday, docker logs, and then -f, and if there is any output that you are getting it from it, you can go ahead and say docker logs Apache. So you can see internally now we didn't tell anything to run as a first command, but the person whoever has created the image, they would have given it in such a way that Apache is automatically running. Okay, so now in this Apache is running, and the port 80 of the application running inside is being exposed to the host machine. So now if I go back and say the same netstat, you can see there's a port 80 which is listening on the host machine. So this is nothing but the map. So whatever that we ran, it has been mapped to our host machine. Okay, and now if I want to access it, so I can just say curl localhost. So you can see I'm able to access the same thing. If I want to access from my browser, then I need to find out the machine details. So since it's a AWS machine, I'll be taking the public DNS. So there you go, it's there. So as long as that container is running, the port will be listening on the host machine, because now using this, what we are doing, we are trying to reach the host machine, and from the host machine we are able to get it inside. Okay, this is one way. Okay, now to show you another example, now similar to Apache, now we also have another popular web server which is called as Nginx. So now think of the flexibility of Docker is that all you need to know, is there an image available in which do you have Nginx pre-installed? So that way there is the image called Nginx which already has the Nginx web server available. So now all I have to do is docker run, once again the same d, because I'm not interested to go inside, just to start it, and -p. Now in this, what happens is I cannot use 80 because Nginx also gives in 80, but 80 is already taken on the host machine. So now I can use any available port on the host. So let's say 8081 is available. Okay, and then the name of the image. So Nginx is the name of the image. But however, here also I'm not giving any first command because I don't know. So that's the reason in Nginx, whoever created this image, they have created in such a way that it should start the application automatically. So that way now let's go ahead and run this. Once again, it downloads the image because we do not have it, and then it will create the container and run it in the background. And now if you go ahead and say docker ps, you could see that it is running Nginx. Okay, and then the port 80 on the container is mapped to the host machines 8081. And to cross check, if you just say netstat and try to grep for 8081, you can see it is listening. And now if I go the same machine, if I say 8081, you're accessing Nginx. So this is how, here, like I told you, if you access 80, you're accessing Apache, which is running in one container. If you access 8081, you will be accessing Nginx, which is running on another container. Okay.
I have one question. Can't
Yeah.
we use the container IP and the port to access the server instead of exposing to the host machine to the port?
Okay, now that is what there is a concept called networking that we need to understand. Okay, so by default, now to go back to this diagram, whatever that the container runs, every container has its own IP, and that will be available only within the machine. But when you're trying to reach from outside, obviously the IP of the container is not visible to anyone else beyond this machine. So that is where the only way that you will be able to access is to map it to the host machine's port and then use it, because your host machine is the one which is available in the network, not your container. Okay.
This is Ravi.
Yeah.
So when we run the Docker for Nginx or HTTPD, so which image actually it will download, whether it is CentOS or Ubuntu, because there could be many images with different OSs in the registry, right?
Okay. So this is where, see, now you need to understand the concept in a different way. What is your interest? So your interest is not a CentOS or a Ubuntu. Now, for me to even show you the demo, I wanted the application. So this is where I didn't worry about what kind of OS that they would have used, because let's see in the later part on how do you create an image. So that way you will be able to know. But to answer your question, now, if you have a specific requirement where you are not interested on the application, but you are interested on saying that, hey, I want Apache, but I want Apache to be running on CentOS, then you need to know what image is available in which they have used CentOS as the base layer and then installed Apache. So that way, it's up to us to find out, because whatever that we are using is more of an open source, so that it is necessarily only for accessing the application. Because for me to show you this demo, it doesn't matter whether it is CentOS or Ubuntu. So that is where we don't worry. But yes, as per organization, if you have such a requirement, then you need to generate your image so that you will have the specific OS as the base layer, and top of that you install whatever the application that you want and then create that image. Okay, so that is where it's important for us to know what is that we want to run, and for that what is the image that is available. Okay, so clear so far on what exactly is port mapping? So going forward, at any point of time, if you have a requirement wherein it's not just for creating a container, but to access a web application, then along with creating it as a container, you need to mention the port which has to be mapped. And this needs to be done only at the beginning. Okay.
Adam, I had a quick question. So whenever you do a port mapping, so does the firewall like basically rules change on the host machine?
No, it is going to be the same. Now, if you understand on my AWS, if I have not added the inbound rule to allow port 80 or 8081, it would have not been allowed, because this is what I told in the last session. Guys, can you
Okay.
please mute?
Hello.
Yeah, so anything that you are running inside the container is the same way
Yeah.
how you are going to run it on your host machine. So if you are
Okay.
trying to run the application directly on the host machine, whatever the restrictions or the firewall is applicable, it is the same, it is going to be applicable here. The only difference
Okay.
is instead of running directly, you are using one more layer or a container and you are running inside. Okay?
Okay. Okay. Yeah, got it.
Adam, I had a quick question. So,
Yes.
can we go back to that slide, please? We understand we cannot use the IP address of the container itself to reach the applications. So I would like to know then, if you're not using the IP address of the containers at all from outside, what is the significance of IP address on the container? Under what scenarios the IP address is being used of the containers?
Okay, so that's where it goes back to the knowledge of how your application is running. So, like now, how we are moving is we will be having something called as microservices. So I might need two components where for my application, I need both of them running as a separate entity. So I can create two containers wherein in one container I will run one component, in another container I will run another component. However, for these two containers to communicate internally within the same machine, I will be using the container IP. But from externally, you do not want both this component to be available. Then only the front end component needs to be available. Then only that will be done by a port mapping. For example, let's say that you are trying to access a web application. Like let me say you're accessing Gmail. Now, to start a Gmail, they would also have an application internally, but it needs another component called database. Now, assume if both of them are running in container, for a user, you are supposed to access or you are interested to access only the front end. So that way, only those which is as a UI, you will be mapping it. But internally, the application should be connecting to the database. Now, that will be available in another container. Then the communication between this container and the other container which has a database component, if you want to connect between these two, then I don't have to do anything like this because all of them are available within the same network or the machine. Then you can use the container IP of another container and specify that to the first container. So that way, it's the connection between these components will happen through container IP. So that's more for a microservice architecture.
I think you're talking about the bridge network, right? That the container provides, like, or the Docker framework. Yeah.
Yeah, I didn't go to that network. I know that's the reason I'm telling, but it's more of a logic where if you understand, if you want to access, okay, if you access outside your network, yeah, then you will be requiring. But when you are trying to access it within the network on the same machine or within the network, then you might be using directly the container IP. So that's the example that I said. When you have microservices, you can go ahead and use this.
So mostly this happens when the application is connected to another API or another component for internally for them to use. This is significant.
Yeah, that's right.
Very clear. Thank you so much.
Adam, can you explain once again that what if one machine, another application is running and another machine, different application is running?
Okay, probably it's a different or a wider topic. Just make a note of it at the end of the class. Just remind me so that I can just give you, because if you get in deeper, it's kind of going to be diverted. Okay, just remind me at the end of the class. We'll discuss on that.
Okay, Adam.
Okay, now moving into the next topic, which is called as data volumes. Okay, so what is data and a volume? Now, in the previous topic, what we were understanding is how do you do a port mapping, in which the simple logic is you had an application which is running on a port inside the container. So if you want to access this from the host machine or outside your host machine, then you are going to do something called as port mapping. In the same way, now let's take a machine in which there is a container and the application is running inside it. Now, you are interested to access not the application this time, but you are interested to access the files and folders which are available inside a container. Like for what purpose? Now let's say your application is running inside the container. So all the files, whether it is a configuration file or it is a metadata file or it is a log file, everything is going to be available inside the container only, right? So that way, now let's say Jenkins as an application. Now, whatever that you try to install and set up in a Jenkins, everything will be available in a folder called where-lib Jenkins. Now, if I ask you as an application, if you want to access the logs, then you cannot access the logs directly from the UI or the port mapping. So this is where what you have to do. You need to go inside the container to a specific folder and then access it. Okay. So this way now you want to go inside the container. Or let's say you want to do something called as a log rotation. So what is log rotation? Now, typically, as you keep running your application, all the log files are going to get stored within this container. So now, at some point of time, you want to purge or delete the older logs, which is what we call it as log rotation. So now for that, once again, I should go inside the container and then see the files which is not needed and then delete. But in that also, you might have to take a backup, because if you have an application like Jenkins or any other application, other than the logs, I want to take a backup of some content which is available or the metadata. So once again, for that, how will you take a backup? Because when I say backup, you need to take the content and store somewhere else outside the container, right? So for all this scenario, the requirement what we will have is, how is that I'm going to access my containers folder of my interest, and the same time, if I need, how is that I'm going to take the content like a folder or a file which is available inside the container to outside. Okay, so that's where now, just like how we had the port mapping, we have something called as volumes or volume mapping. Okay, so now what you can do is, when you are creating a container, like how you exposed a port, now when you're creating a container, you can also kind of expose a folder. We don't call it as expose, but just to correlate and it will be easy for you to remember, you can say that you are trying to expose a folder. So now the host machine will be knowing that, okay, there is a folder which this container is allowing me to share. So that way, when a container is getting created, you can share a folder and all the subfolder of it will also be shared to the host machine. And that you can map it to another folder which is available on the host machine. Like how you mapped the port number. In here, what we are trying to map is folder. So a folder inside the container will be mapped to a folder on the host machine. So such a way where you are trying to share a folder from a container to the host machine is what we call it as a volume. Or in simple, the shareable folder which is available inside the container is what we call it as volume. And since you are trying to share some data, these are also called as data volumes. Okay. So now what happens is, when you're creating a container, you can share a volume, which is nothing but a folder coming from the container, to a folder which is available on the host machine. And now what happens, as per this diagram that I've put, now if I create a container and share the volume which is where-lib Jenkins, again, volume is nothing but a folder inside a container which is shareable, to host machine. So now if I go to host machine, under var log, I'll be able to see all the content of this folder and its subfolder. So that way, instead of we going inside the container to access this, I can directly go to the var log on my host machine, and if I access the files here, I can directly access the same content what is available inside the container. So without going inside the container, now if I want to take backup, I will take all the backup from here, because now in varlib Jenkins, you will get the entire home directory of Jenkins here. So now if I want to access the log file, whatever the log file is available here, I can access directly here. Same way, if I want to delete some file, I can delete. If I want to take a backup of the Jenkins home directory, I can take the backup of the contents from my host machine under var log. So this is how you will be able to access all of them. Okay. And when I say volumes, it is not one way of sharing folders, it is two way. The meaning of that is, if you map a folder in the host machine, and if you go inside, you will be seeing the content of this folder which has been mapped. However, if I want to modify something inside the container, I don't have to go directly. Again, I can use the same folder. Okay. Now let's an example. Suppose if I want to modify my Jenkins configuration file, then I can go and directly see here, because the var log folder will be showing me all the files which is available here, right? So any changes that I do here is going to directly reflect inside this folder. So that is how, depending on your need, if you are trying to take a backup, okay, or access some metadata, then you can go here and access. The same way, if I modify some file over here, that will also be directly changing here. So this is where, now if a requirement comes that you want to change some configuration of the application, you don't have to go inside the container. You can directly do from the host machine, or if I change some file here, that is the file that will be changing it internally, and the application will be reading your files accordingly. So that is how volumes are nothing but a shareable folder from container, which you can map it to host machine, or the simple logic is, from container you are mapping it outside. Okay. Now the reason why I'm saying outside, not just to machine, is as you move on, it's not just Docker what you will be having, but you will also have one more layer for orchestration like Swarm, or to the extent of Kubernetes as we have latest. So in that way, there are ways where you can create a volume from the container, and either if you want, you can share it to the host machine, or you can share it directly to a cloud also. So that way, there's a different logic called persistent volumes. Okay, so as you go through a different orchestration tool, you will get into that. But here, the logic of volumes is all about how can you share a content from a folder outside it. And if you're using the Docker daemon, it's just one machine, right? So in this, a volume is nothing but a folder which you are sharing from the container to a folder which is available on the host machine. Okay. So this is the concept which we call it as volume mapping. Now, like this, I can have multiple containers, and in each container, I can have different folder. Okay. Now, let's assume I have one scenario where I have different containers in which same application is running. Okay. Or different applications. But what happens now? I want to check the logs of each and everything. So instead of me going inside each container, if I can map whatever the respective folders that I have to a particular folder on my host machine, then what happens? If I go inside the var log, I'll be able to see all the files that is available in varlib Jenkins and this particular etc app from this container. So that is how, from one folder on your host machine, I'll be able to access all the logs or whatever that you are sharing from the different containers. Okay. But however, you need to understand that if you are doing something like this, then if there is a file which this container is trying to share, And if this container is also giving the same file, then whatever the later does will get overwritten. But this is where what we need to know is each file that the container is trying to share should be unique. So that is where I'll be able to go inside and I'll be able to see everything separately. Okay, but the other way is now I don't have to go inside each container. I can just map the respective folders from the container, which is a volume, to my host machine. Okay, and not just this, like I said, it's a two-way. Now if I want to share something to this container, then I can go to this folder and modify. This will be coming. And the same time, this is also used for communicating between two containers. Now, for example, if this container wants to share some file with this container, then think about this. If you put something here, okay, it comes to the volume, shares it to the host machine under Verilog, and anything that is available here is also going to be directly available in this folder. So that way volumes are also used to share between these kind of containers in a microservice architecture. So it is always up to us to decide on how the content should be shared. So this is just another scenario where if you want to share some files between two containers, like for some application communication, then you can also use it in this way, or you can use majorly for folders, and you can access the log. Okay, again I request everyone to go on mute. Anyway, so this is how, when you say data volumes, these are nothing but a folder which is available in a container which will be shareable to the host machine, and it will be a two-way folder. And once again, this needs to be done when you are creating the container. So after creating the container, you cannot say that no, I want to map this folder. So while you are creating the container, you need to decide what will be the volume or the folder which you want to share, and that where it will be available on the host machine. Okay, so
question, when we are distribution, this folder structure will not be maintained, right? As it is, the content will be dumped into that host machine directly, right?
Mohan, your voice was not clear. Can you repeat or type in the chat?
Is there any way folder structure can be maintained in this two-way sharing from container to the host?
Yes, whatever that you share, that's what I'm saying. Suppose if you have some folders under Verilib Jenkins, the same folder structure is what you will also have on the host machine. But again, if you want to have the same name called Verilib Jenkins on the host machine also, you can do, provided if the folder is available, do it, or you go ahead and create it and apply. So that way it's just a folder, right? Similar to port number, it is not mandatory that you should have a different folder. If you want, you can also have on the host machine also the same folder structure. That will work.
So that user has to take care of that. It's not that automatically the folder structure will be happening.
Yeah, that's where it's from the person, whoever is going to create, you need to decide and plan accordingly. Okay.
Yeah, thank you.
So Adam, if you are running a database, right? So in the database, we have redo logs, commit logs, and all of it. So we can map everything externally to a folder.
Yes, you can have one folder being mapped, or you can have multiple folder being mapped. So that way you need to choose on the host machine different folders. So depending on your need, you can go to the respective folder which has been mapped to a folder in container, and you will be able to see the access.
Okay, so even if our database service goes down, then we will have everything so that the state could be recovered at a later point.
Exactly. Now that is where it's not very straightforward, where you can take a machine. Now that's where I was talking about something called as persistent volumes, so which is not very straightforwardly available in a Docker, because Docker is just one machine in which you are installing and you are trying to manage. To handle the scenarios that you are talking about, you need to have a volume which is shareable across machines. Okay, so that is where then the folder, whatever that you have on the host machine, should be a NFS shared, or it should be available on the cloud. Okay, so that's again more and more into orchestration. But here, to understand the simple logic, all of them are called as volumes, wherein here, since we are trying to take one machine, using Docker, we are trying to share it as a volume to the host machine. But however, when we move into orchestration, you will get those options where I can share it to the machine, or I can also share it to NFS, or I can share it to cloud on a different machine.
Okay. Okay.
So in other words, even if the container goes down, we still have very much, we can access the logs wherever it has been shared, right?
Yes, I'll tell there are a few concepts I'll explain you, but if this is clear, where volumes is all about sharing the folder from the container to the host machine in the Docker level. Okay.
Just to
Adam,
rephrase this, I'm sorry, Adam, just to rephrase this, the contents of the logs are actually copied from the container to the folder where it is shared. Literally,
Yes,
it is
I'll
copied,
talk
right?
about it. I'll tell you that.
All right.
Adam, is this something like a symbolic link? Like we have the sharing, right?
That's what I
It's
was
not
about to
exactly
ask. Yeah.
symbolic link. I'll tell you the difference. I know, but I'll tell you the difference. Just give me 2 minutes.
Okay.
Yeah, Adam, is there any chance to share the volume from container to another container without using the host? Is it possible?
See, that is possible, but right now, again, for that, you have to use volume. So when you're using the Docker daemon alone, which is available one machine, then the only way to share between these two is what we have it as volumes, which is mapped to the host machine. But however, like I said, there is orchestration tool. So if you use a tool like Kubernetes, we will have a concept called persistent volume that will be beyond a machine. Then rather than storing it on a machine, you can store it on a different location. Okay. So that's when you go into orchestration tool, you will be having all the options. But regardless of that, if you want to share something from one container to another container, then it has to be through something called volume. So volume helps you to share the content from a container outside it. That's where I'm keeping it open outside. That outside can be a host machine or it can be another container. So you need to create it as a volume.
But those containers are in the same network, right? So we can share it within the shared folder, or is it like same IP address? It will be the same network, so we can share that, right?
Yes. All those things is going to work only if you're in the same network. So that is where don't kind of mix orchestration concepts over here, because whatever you are asking, most of them is on the multiple machines, multiple containers. Okay, but here to go to that level, the first understanding is on one machine how it is working. So that's what the whole point we are trying to see. So with this, later on, whenever you learn the orchestration, that's where this will be acting as a basic for you to understand. So in simple, in Docker, if you want to share something from a container as a folder, it has to be a volume. Now, whether that can be as a volume mapped to the host machine, or I can directly map the volume from one container to another container, or I can map the volume from the container to a cloud and access it on another machine or another container on another machine. So all them is orchestration. But in simple, how is that you can share something from a container? That logic is what we call it as volume. Okay.
And
Adam, also, please go ahead.
yeah, my question was with respect to managing the state. So anything with regards to the state for a container, is it also part of the orchestration?
Yes.
Okay. Okay.
Adam, could you please take me back to that slide? So as we are dealing with the shared volumes here, the Docker volume, shared volume, this concept is limited only to file management, or as you were saying, we can also change the configuration files in the containers, the applications. Is there a way we can execute some commands also there, or is it limited to only file management?
Okay, it's only to files and folders. Okay, you cannot typically run anything, because now if you go to this folder, you are actually on your host machine. So any OS command that you are running is actually getting executed on the host machine. But however, that will be applicable to the file. So anything that you change as a file is what only going inside, because even in your regular NFS sharing from one machine to another machine, What is that you are doing? You are trying to share a folder from one machine that you will mount it on another machine, right? So in that case, now if you get a mount of a folder from one machine to another machine, whatever I'm running on my second machine is just by accessing that folders. So I'm not doing something by running a command there. So that way this container is trying to give you only the folder and the files. So that is what you will be able to access. But that can be a content, or it could be some kind of metadata or some configuration. But anything that you want to run as an application or run as a binary, that you have to go inside the container only.
So Docker volumes is all about the purely file management, that's all.
Yes, files and directories.
All right, thank you.
So like I was saying, how do I make sure that while creating the container, this will be done? Now, exactly in the same way, like how you gave -p, you're going to give -v, which stands for volume, and the same logic of this. So you're going to say hd, which and then cd, which refers container directory. So let me just elaborate it here. The same thing if I want to do, I will say host directory and then container directory. Okay, so now to give an example, okay, now let's say I'll try to create a volume. Now this way I want to go inside the container to show you guys. So this way I'll say docker run -name. Okay, let me call it as C1. It's just container one, and then I'll say -it and then -v, and followed by, now let's assume on my host machine I'll create temp host. Okay, and then inside the container, let's say temp container. Now by default, if these folders are not available, it will get created, but just to show you, this is what we are going to do. And followed by, let me use the CentOS and bin bash. So I'm trying to go inside the container in an interactive way in which I'm trying to share. So let's see that first. So now if you look at my host machine, on the temp folder, you do not have the folder called host, correct? So this way what will happen now, as we create from the container, there will be a folder called temp container coming, and that will be going to the host machine under temp host. Okay, so watch this. So I'm inside the container, and then obviously if you go, there's the folder available and there is nothing. Now let me create a file, dummy. Okay, now to show you this, let me take another screen and let's connect to So now if I go to the same host machine, under temp, you can see there is a folder called host, and you can see that dummy is available. So whatever that you are trying to put inside the container, okay, probably I'll minimize this. It is available on the host machine in this folder. Okay, same way. Now, if you try to do some change here, let's say I'll create another file. So it's available inside the container. Now the same thing, if you go, it will also be reflected. So this is where anything that you modify in this folder and its subfolder will be available. And it's two-way, which means now if I modify something here, okay, now let's say that I create a file here. Now the same, if you go inside the container, it will be available. Okay, so that is how It's a two-way shared volume. So anything that you store inside the container in a particular folder. Now, typically, this is what we call it as volume. The temp content or temp container is called as volume, and that you have shared it to the host machine under temp host. Okay, so this is two-way. Now, you might think it's simple, but how you are going to access is what is more important. Like I was saying, the example here, if it's just a single folder, then it is fine. But if I want to access it from different folders and different containers, then I can map it to a particular folder on my host machine. Then I can access across multiple containers. And the other beauty of volumes is, look at this. Now, whatever that you're trying to do on your container on this folder is available on the host machine. Now, it is not mandatory that the container should be running in order to access this particular folder. So this is where if you have an application which is running inside the container, for some reason, if the container gets crashed and it gets stopped, now, even though it is stopped, the folder which has been shared as a volume will be available on the host machine. So the only point is, as long as the container is available on the host machine, this volume will be available for us to access. Okay, but if the container itself is deleted, then you will not be able to use it, but a copy of that will be left over on the host machine. So this is where it's not like a direct symlink, okay, but typically you can think of it like a hard link, where now it copies the content. So whatever that you're doing inside the volume is actually getting copied on the host machine. So that is where, as long as the container is available, you will be able to see this. But if the container is deleted, a copy of that will be left over on the host machine so that you can refer it for later. Okay, so that is the best practice, where whenever you are creating a container, you need to make sure, especially the metadata or the log files should be shareable as a volume to the host machine, so that even if the container gets crashed, and if you actually move into the orchestration world, you don't need just one container. If the container goes down, you should be able to recreate. Now that facility is not available in the Docker straightforward. That is where you are going to use the daemon, or you are going to use orchestration tool like Kubernetes. But the concept is, when you are doing something like that, then I need to know why my first container stopped or failed. So that way, if you want to check the log, container will not be there. However, if you have done a volume mapping, all those logs will be available on the host machine or wherever you have kept the volume, which you can access. Okay, so now see this. If I do exit, my container is not running. Yeah, typically these two processes are still running, which is Apache and Nginx. Now, if I come to my host machine, in my host machine, you can see I can still access the content which has been shared from the volume. And for example, if I want to just delete it, let's say I'm just deleting this file. Okay, so I've deleted a file. Now obviously all these things will be reflected in the volume. So when you bring back your container, whatever is available on this shared folder from the host machine is what you are going to get inside the container, and the container will be behaving depending on the files. So this is where I was telling you, suppose if you want to pass a configuration, you can pass a configuration here, and then when you start your application or container, it will try to read the files which has been shared, and based on that it will be coming up. So now if I start the container again, okay, so you can see it's running. And now if I go to temp, you can see this is not available. Okay, so that's how, remember, the benefit of volume is not just to share the content from the container to the host machine, but you can also get it in the two-way, where if you change something on the host machine, it'll also be coming to the container. And it's not mandatory that the container should be running. Even if it is not running, you can access the logs, but it should be available. Okay, now just look at it. I'll do exit and I'll say docker rm c1. Okay, now if I go back to the host machine, you can still see that the file is available because it was taking a copy and it is putting up into the host machine. Okay, that's the advantage. So now if you understand by this, when you try to stop a container and bring back, whatever the content that is available, it is bringing back. And volume is actually also another folder which is available inside the container, right? So how it does all these things? So this is where on the host machine, if you go to the folder called where-lib docker, typically Docker stores all the metadata about what the daemon is doing. Okay, so you can see a folder called image. This is where each and every image that you're downloading, the layers of that will be stored. And each and every container that you're running on this machine is going to be tracked in this folder called containers. Again, it's not a straightforward folder where if you go inside it, you will be able to see the content of the container, but it's just metadata. And in the same way, do you see here? There is
Adam, is it kind of a event viewer kind of thing?
It's not inventory, but this is the metadata folder for Docker, wherein all those things that you're trying to do is going to be maintained. And whatever the volumes that you are creating in every container on this machine will be actually getting stored in this folder. So that is where even when a container is not running, you will be able to access the volume, or when you stop the container, whatever the content of the container is actually getting stored as a metadata under this folder, so that when you start the container again, with respect to what is the content here, you will be able to get it back exactly. So the content, whatever you are storing inside a container, is actually getting stored on the host machine under this folder. Okay, so this is where, now if your question is, okay, how RAM is being picked up, it is picking up directly. But from where is it picking up the hard disk? It is from this location. So it is necessary for us to make sure that the where-lib docker folder has enough storage, because whatever that you are storing inside the container is being taken from the file system of where-lib docker. So if you see here, whatever the disk size that I have in this folder is what inside every container you will be getting it. So it's quite important for us to make sure that this folder has enough storage for us so that each containers can create. Okay.
Adam, hi, Deepak here. This is for Linux server, right? I mean, Linux OS. How can we check these things in Windows, or I mean, Windows systems also?
Everything has its own folder, right? Just like how you have in where-lib, if you go to Windows, there is a specific folder structure in which Windows is going to store, or Docker is going to store everything on Windows. So there is a metadata folder in which everything will be maintained. Okay, so that's the only difference, because in Linux you start with root, whereas if you take Windows, it's going to be C drive.
Yeah, agreed. Got that.
Now, just to show you this, now let's come back. Okay, I'll show you this screen. So if you say docker ps-a, how many containers we created from yesterday? So let's say, now typically around 13 containers is what we created, right? Now, you are inside where-lib. Okay, if I go under where-lib docker and containers, okay, you can see if I say ls, you will see that number. Okay, so the docker ps, whatever it shows is this, wherein you can see each one of them is nothing but the container id. Okay, so that's where I said that Docker is somewhat similar in the workflow using Git, because in Git, every time you do a check-in, what you're going to get is a 40 characters SHA-SUM or checksum value. The same way in Docker, every container will also have a unique ID. Okay, clear until this?
Yes, Adam.
Others,
Yes, Adam.
is it clear on what you exactly mean by volumes and how you can share in Docker?
Yes, Adam. Very
Yeah,
clear.
yeah.
Yeah, Adam.
Yes, sir.
Okay.
Yes.
Okay. Now, let me not get into deeper, but just give an idea. So this is where, so far, what did we learn was what do you mean by container management, right? So what we did, now at any point of time, there is an image which is given to you, or you need to know which image that you want to use, okay? And then based on that, how are you going to create container? Whether it is attached mode or detached mode, what name to give, and what kind of application running. Based on that, you have to do a port mapping, or you're going to do a volume mapping, and decide what should be the first command that you want to run, or leave it to the default command. So that's completely about how do you create containers, start, stop, restart, attach, and see what is happening inside it. And even we saw a command called docker exe, using which you will be able to go inside. So this way, now if your requirement is that, okay, I tell you, hey, you are just going to create a container for your development work or testing work or deployment work for whatever the purpose you have, then you should be aware of what is the image, and from that image what port number it is going to come, because it is mandatory that you should be knowing, or you need to work with someone who is going to share you those information. But without that, you will not be knowing. But when you talk about the whole DevOps world, there are a lot of things that we have to do using Docker. So that way, the first work what we were trying to understand is, if an image is given to you, how are you going to use it and create a container? Okay, so that is what the first part called as container management. But however, there's another important part which we call it as image management, or managing image. So this is where, now in an organization, DevOps doesn't mean that, okay, now I take a container or I take an image and create a container. So that is only as a user level. But if you want, you can also create an image, or in the other way, there is someone who has to create an image for our company, just like one person was asking, hey, I don't want Nginx or I don't want Apache to take randomly from open source, because you don't know whether they have CentOS or Ubuntu in it. So depending on your company's need, you need to generate your own image. So that is where you need to know how images are being built. So we don't say creating image, what we call it as image are built. Okay, just like how you build an artifact like a jar or a var, the same way we are going to build an image, which is what we will be using in the organization. So from a high level, how does that exactly work? That is what I'm just going to talk quickly today. So when you say image creation process, now this is like a chicken and egg story. So if I ask you the question, which came first, chicken or egg, then that's going to be a big debate. The same way here, when I say you want to create your own image, then what you're going to do first is you're going to take a image which has only the content that you need as the first layer, which is what we call it as base image. Okay, so typically now if I'm going to create my own application image, now let's assume that I want the OS layer of CentOS. Then I need to take first an image which will have only CentOS files in it. Now that image is what we are going to call it as base image. So again, just like in the sandwich, whatever the first layer that you're going to keep on the top and the bottom, that's what you call it as the basic layer, right? The same way in an image, the first layer that you're going to take, which will have your basic requirement, is what we call it as base image. Now using this base image, you will be creating a container. So now when you create a container, what happens? Whatever is available in the base image, you will get it inside the container. And now in this container, you can go ahead and do whatever the activity that you want. Okay, so you can run some application, run some OS commands, create a file, whatever that you want. But every command then you're executing will be actually stored as a layer inside your container. Okay, so that way now what happens? Let's say that I took a image of CentOS, I created a container, and I went inside and ran yum update. Just an example. Then what happens? There will be a layer created on top of this, which will be having the files updated. Then assume on top of that, I'm going to again install a package. Now let's say when you take CentOS, you will not be having anything. That's the reason I told that it's something like a vanilla flavor. Now even if you want to access a basic editor like VI editor, you need to use yum install and VI. Now let's assume you do it. Then that is also stored as a layer. Now on top of that, let me say that I will create a new file. So this way, every change that you want to do, you will be doing it inside the container. And then when you have your container with all the things that you need, then you are just going to make a copy of this and create it as an image. So now if you see, I can directly create an image which will be nothing but the copy of what you had inside the container. And then this will become read-only. So now if I take an image, so in my final image, I would have multiple layers, so that I will have CentOS, and top of that the yum updated files, and then on top of that, if I have installed the package called vim, and then on top of that I will be having this file. So now if I give this to anyone, what happens? Everyone will be getting the same. Or for my testing, in the very beginning I was telling you in the Docker explanation, if I want 5 copies of this, all I have to do is take this image and create 5 containers separately, then all the 5 containers will be exactly the same. So this is how, if you want to create your own image, then you need to first take a base image and create a temporary container, and then put all the steps that you want, all the files that you want, and then create an image from this, and this will be your final image. And like this, what people would have done is, whether whatever that you have seen as a Ubuntu or CentOS or Nginx, or even typically as you move forward in your organization, you are also going to do the same. So depending on your need, you will take a base image, put all the necessary files in it, and then create a final image, and this is what you are going to store in your registry, so that anyone now wants to work, you need to tell the name of the image, and from this image what are the applications you are having, all those things. Okay, so this is just a simple way of showing you to understand. But remember this, how do you create an image? If this is a question in the interview, even in that way, it's more about taking a base image, and then on top of that, in a container, put whatever that you need and convert it into an actual image. So like this, I can create my own image however I want, because someone else, if they want, they can take this image, create a container, put some more layer on top of that, and create a new image. So that's how everything starts from the scratch, which is called as base image. From this, you can keep adding how many other layers that you want and keep creating your own images. Okay, so this is the whole concept of how you are going to create the image. But when you're creating image, there are different ways. Okay, so one is, what we will see quickly is interactive, which is called as manual way. But however, as you go into real time, it's not possible to keep doing all these things manually. So what you have to do is you have to automate. And when you have to automate, that is where the concept of Docker files and other things will come. So for now, let me just quickly show you how interactively you can create an image, or in very simple, how manually you are going to create an image for yourself on your machine. Okay, so okay, now quickly, whatever that I showed in the diagram, I'm going to do this. So let me take up a container, and I'll say name, and let's say test03. Okay, and I'm going to create it interactively, and I will use CentOS. So now I'm inside the container. All I have is only the CentOS files, nothing inside it. So let me go ahead and say yum update. Now it's the same thing, whatever I showed you in the diagram I'm trying to do. Okay. So now let's go ahead and say yum install -y vim. Okay. Okay, now I have installed Vim. Now using Vim, let me just go ahead and create a file called temp test. Okay. So you can see now we did the same thing, whatever we have here. So we try to take CentOS, updated, installed Vim, and created this file. So now let's just convert it into an image. So how do I do that? Now for this, first let's come out of this. And now, if you want to create an image from a container, just like in Git, if you want to convert your changes into a check-in, then you will use commit, right? The same thing over here. We are going to say Docker commit, and now you need to tell the container ID or the name of the container. So the name of the container was test03, and followed by that, you are going to give the name for your image. Okay, so let's say I'll call it as test img. So now from the content, whatever that you have in the container, it's going to create an image wherein it is going to take all the layers, whatever that you have put, and convert it into a image. So that in the new image called test img, we will be having all this. So now if you want to see what are the images available on your machine, you can just go ahead and say Docker images. And that's where you can see now from the beginning, yesterday we took CentOS and Ubuntu, and then we took Nginx today and Apache, and along with this, what you have is called as test img, which is what we created. And when you create an image, it will be available on the same machine, or the daemon will be maintaining it on the same machine, just like your Git. So the check-in that you do will be converted as a commit ID, and it will be available on the same machine, right? So now I can create as many containers that I want from this. So that now see, if I just say docker run -it, then I will take test img as my image name. So now what happens? If you go inside it, first you will be having the OS, which is CentOS, and then if you try to do yum update, it will clearly tell you that it's already update, nothing to do. And now if you want to check out the file, you can see there is a file called test, which is available, and your Vim editor, which we installed, will also be there. Okay, so this is where what happens is, if you want to create your own image, all you have to understand is the workflow will be take a base image and then create a container with that base image, put whatever the things that you want or whatever configurations that you want to do, and from this you're going to create it as a final image. So like this, it all depends on what is the base image you are taking, what are the layers it has, and then from that, what are the layers that you are going to put by modifying or configuring inside your container. So everything will be stored as a layer. Okay, so this is the generic way on how we are going to do. But however, like I said, I'm going to stop it now, so that in the next session, we will get into deeper on how you're going to do this automatically. And that is where the whole concept of naming comes. And even for the image, if you have looked very carefully, there is something called as an image ID that we are going to understand. And then we are going to talk about the registry. Okay, so that's where more of the image management comes into the picture. Okay, so I'd like to stop the session by now. And again, once again, thanks everyone for joining. And my name is Adam.
Adam,